Hello teacher, my name is İsmail. Now I'll explain how this program works. We have three classes in here. One of is node, other one is DQ, and last one is DQ demo. And I'll explain what these classes works. First one is node class. This class represents an individual element in the DQ. It holds the data and references to the next and previous nodes. In the queue class, this class represents the double-ended queue itself. If it supports operations to add and remove elements from both the front and the back. We have a lot of method in here. The last one is the queue demo. This class serves as a demonstration of how the DQ works. It creates a DQ, adds elements to the both front and the back, removes elements, and check the state of the DQ. Okay. Now I want to explain these methods in here. What these method works. In here, we create a new node and adds to the front of the DQ. If the DQ is empty, both front and back point to the same node. We can say like this. For example, our new node is A, front equal to A and back equal to A. This is for empty element, empty class. I'm sorry, empty DQ. If DQ is empty, both front and back point to the same node. So if it's not, the new node is linked before the current front. We can see in here. At the back is same like at front, but it's different. It creates a new node in here, and it adds it to the back of the queue. If the queue is empty, we check in here, and both front and back point to the same node. We can define in here this, and if it's not, the new node is linked after the current back. Okay, let's see remove front. It removes the node at the front of the queue in this part, in this method. If it was only node, both front and back become null. Otherwise, front moves to the next node. We can see condition by condition in here. But there is an exception in here. If the queue is empty, it will give an exception. So we check the is empty method in here. Remove back is same like remove front. Removes the node at the back of the queue. If it was only node, both front and back become node. Otherwise, back moves the previous node. But the class, the queue is empty. If the queue is empty, there's an exception in here. Okay, there's a get front method. It returns, this method returns the data of the node, the front of the DQ, throws an exception if the DQ is empty. We can see in here. And get back is the same like get front. It returns the data of the node at the back of the DQ, throws an exception if the DQ is empty. And there is a empty method. It returns the true if the DQ is empty. Otherwise, it returns false. And clear method is clear all nodes our DQ. It resets the DQ by setting both front and back to null. We can see in here. Now let's see our demo program. I want to add breakpoint in here, and I will start with debug. Okay, let's see what's happening in here. In this line, we create a new instance of the DQ class. It calls the DQ constructor. Okay, let's see DQ constructor. Yeah, it initializes an empty DQ, so both front and back are set to null in here. That's clear. Let's skip fifth line. In here, there's a print message adding to the front A. It will write this to the console like this. And we call the add to front method right now. We will add to the front this element. So we will go to the Q class for add to front method, and there is a new, we can see there is a create a new node with node class from the node class, so we skip in node class in here, and a new node with data A is created right now. Our data is A, and this data equal to A, and its next and pre equal to null. So we define it here A. Now A is created. Our object is created right now. Okay, when we back in here, since DQ is empty, front equal null, both front and back are set to the new node. So our list is empty. We check the is empty method, and back, yes, our list is empty, and we add to the queue right now. Yeah, our first element is A. We stick it and we back to the queue demo. Now we wanna add adding to back B. Add to back method, we will call add to back method, and we write the console this line we can see in here, and we call the add to back method. When we go to the DQ class again, we create new node. Okay, from node class we got the node class. Now our B is created in here, and when we back to DQ again, since the queue is not empty, we can check with this. The current back not next points to the new node. The new node is previous, so point to the old back. The back is update to the new node. It's not empty right now. We check it's false, so we will skip the else block, and we come here. We skip the if block, and let's run the else block. Back dot next equal to new node, and new node previous is back, and our new back is new node, so it's equal to B. Okay, we'll back to the Q demo again, and we print the console this line, adding to front C. Now we call at front again, and we will back, and we create from node class a new node. It's B, it's C, I'm sorry. Let's see, we create C in here. Now if block is not empty, so we skip this part and we run else block. We check is empty method with, and we skip if block. Our new node next is front previous is new node, so our front is equal to C. Okay, now let's call the get front method. It will, I explained it, the front of the DQ element, it get this element, so our last element is C, and back we can see in here, we check is empty method, there is element R in DQ, so there is no exception in here, and we check the is empty method, and we back, we skip this line, and return front data. So it must write this. Front is C. Our last adding element is C. Now let's see get back method. It's same like front, but it get the back of the method. So our back element is B. We can see in here. Let's see. When we go to get back method, there is a empty method. We check again, and it's not empty, so we skip this line, and it returns the back data. So it is B. Now remove front and remove back methods. We check them. When we call remove front method, we skip the DQ again, and there is a empty method. We check the queue is empty. If it's empty, there's a runtime exception, so it's not empty. We check with is empty method. Now our this line is finished, and key data is equal to front data, front equal to front next. It moves front to front next. If new front is not null, its prev is set to null in here. Else sets back equal to null. Not needed here because still element is exist. So we can see in here we skip the else block and return the data. Okay. Remove from front is C. Now remove back. We remove the B element we want to remove. So saves data. Let's see. In here we check again, and saves data B from back. So moves back to back dot prev. If new back is not null, its next is set to null. We can see in here. We skip this line again, else as part, and return the data. And our removing from back is B. Now get front. We check the get front. Now our element is A only. We remove A, B, and C. So get front and get back, these are the same because our element is only A. So we can see our list, our queue is not empty, the queue is not empty. So front data is A right now. So the queue clear, we call the clear method, and front equal to null, back equal to null. So in our DQ there is an empty DQ. So when we check with is empty method after applying the clear method, we can see true. Return front equal to null. Yes, it equal to null, so it is true. We can see in here. This is our program. Thanks for listening. See you next week.